Okay, so I'm gonna actually record this now so I can put this up on YouTube for you. So okay, so how do we solve? So what's the strategy when we got a couple logs?
Subtract the log off.
Yeah, exactly. So the plan, one, get the logs on the same side. Yeah, good idea. So grab this log and jump him or subtract them. Same thing. You're totally right. So this will become log base 3 x plus 2 minus log base 3 x minus 3 equals 2. So there we go. So step 1, get the logs on the same side. And remember, what do we do now? Yeah, it becomes divide. Yeah, we're going to, remember I said count down. Maybe that'll help you. Right, go to divide next. Yeah, exactly. Remember we count them down. It's going to be 2 logs, 1 log, no log. So 2 logs, 1 log, no log. Count down the logs. I can read my writing there. Sorry. Count down the logs. So subtraction becomes divide. Adding becomes multiply, right? Remember the properties? So we have subtraction for 2 logs. That's going to become divide for 1 log. Can you do that real quick? Okay, so these 2 logs will become 1 log base 3, and I'll divide those, If that was a plus in the middle, if this here was a plus in the middle, then it would have been multiplying. It would have been log base 3 of x plus 2 times x minus 3, wouldn't it? We good with those 2 rules? Subtraction becomes divide, adding becomes times. So this was subtraction. So it became divide. Good to there. Now what? Now, so I went from 2 logs to 1 log. Next line, I want no log at all. So how do I get rid of this log? Base 3, both sides. Perfect. And then it just cancels that out, Because powers are the opposite of logs. I think you know that quite well at this point. So then, what does that leave us? X plus 2 over x minus 3 is 3 squared? 9. Count down the logs. So now we've got no more logs. So now step 3 is just solve. And then step 4, check. Now I would encourage you when you get the exam tomorrow, part 1 in your hand, to write a C next to this kind of problem. Any problem that begins with logs and an equal sign, to put a C or a check mark or whatever you want, to remind yourself that you have to check the answers in the end for log problems. Remember that? Okay. So what do we do? What's our next step to solve? We're on step 3, solving. What do I do to solve when you got a fraction on one side, whole number on the other? Cross multiply? Yeah. Put this over 1, diagonal. 1 times x plus 2 is 9 times x minus 3. And then just distribute that. Boom, 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 boom. X plus 2, 9x minus 27. We're close. Now we just solve for x. I'll subtract x from both sides. 2 equals what? 8x minus 27, if you can read that there. I just canceled this one out. So I'll bring it over here. 2 equals, so I'll kind of run out of room. Bring it up here maybe. 2 equals 8x minus 27. Add 27 to both sides. Boom. So 29 is 8x. So 29 is 8x. Last step. Divide by 8. There it is. 29/8 maybe. We have to check it. It could be no solution, So we have to check it. Now, the check is pretty quick. I would just take my calculator, take 20. Oh, sorry, don't calculate on this part. Okay, what whole number is that? What whole number is that? 29 divided by 8. 8 goes into 29 about how many times? 3 something, Just 3 point whatever. I don't care about this. It's all you need to know. It's 3 point something, right? Because 3 times 8, 24. and a little more, right? So it's 3 something. Okay, so if you put in a number that's 3 something, like 3.1 even, right there, the inside, remember, you just can't have 0 or negative inside of a log. Anything else is okay. So 3.1 plus 2, that's fine. How about here? 3.1 minus 3, it's not 0. That's why it's important to know he's bigger than 3, huh? So he's good. That's my answer. He's a keeper. Remember, if he makes the inside of any log 0 or negative, then you throw him away. It'd be no solution in that case. But this one's good. Good there. Remember logs? Questions? Solve for x here. Yeah. Because we're always doing the opposite, huh? You probably got the hang of that real strongly. Always the opposite. Opposite of e is ln. Yeah, so we ln both sides. And the ln and the e cancel. And so we just get x plus 7 is ln 5, and then we just subtract that 7, huh? So x is ln 5 minus 7. That answer's probably there. Oh, it's disturbing, huh? But it's none of the above. It's all right, right? Good. Questions on that one? All right. I'll move on to number 3. 3 to the x is 17 to the x minus 2. Okay. 3 to the x is 17 to the x minus 2. Did I get that right? 3 to the x minus 2. Yeah. All right. So there's number 3. Okay. So again, I know there's so much to remember. You have your 3x5 card, but there's a lot on it for this one, huh? Mostly probably, I'm assuming you put all that parabola, hyperbola, ellipse stuff on the 3x5 card. That's the most tedious stuff. Anyway, so x in power. That's why, part of why, I also want to be a history teacher, but that's part of why I told the story about the Hitler thing. When x is in power, I want to key your memory. When the wrong person's in power, got to get him out of power, ln, right? ln does that. ln is the opposite of powers, right? That's why they made logarithms to be the opposite of powers. So when x is in power, log both sides, and then that x will drop down. X will drop down, and the x minus 2. Okay, so where does that leave us? X ln 3, x minus 2 ln 17. Now, if I just write it that way and don't put parentheses around the x minus 2, it's wrong. Because written this way, it only means the 2 is multiplied by the ln's, right? It means x separate and 2 multiplied with ln 17. That's not right, because the whole x minus 2 was the power, so the whole x minus 2 must become the multiplier. Make sense? And now, why that matters functionally is because that tells me what to do next. Distribute through the parentheses. Right, that's what we always do when we have something on the right side or left side of parentheses, huh? It just multiplies both the items, distributes through the parentheses. Now, when you do that, that ln 17 is just one thing. You know, that's just a number. We could get it on here. We're not going to. But you could type ln 17, right? No calculator this part. But my point is, you know it's just a number. It's just a fancy number. Just do with it what you would do with any other number. You would just multiply both the items inside, right? So x ln 17 minus 2 ln 17. Is that good? Seem natural enough? Just like a number, right? And now, what thought should we be having now? This should catch your attention. Now, what do we have to do? Remember, I gave you a game plan. When you have x and 2, we've had it before. You'll have it in calculus.
So move that x over to one side.
Get them on the same side. Yeah, factor it out and divide. Exactly. That comes up a lot. So when x is in 2 places, you get the x's on the same side. Step 2, factor out the x and divide. Exactly. So when x is in 2 places, get those on the same side. So jump this guy over here. It'll become x ln 3 minus x ln 17. And the other minus 2 ln 17 just stays where it's at because it doesn't have an x. So get the 2 x's on the same side and then factor out the x. That's how we're going to isolate it. And last step, divide. Divide by ln 3 minus ln 17, ln 3 minus ln 17. Boom, boom. There's our answer. So can I cancel out those ln 17s? Why not? Costco says no, right? We good? Right? Remember, it's because of this minus sign right there. Right? The top is fine. This ln 17 the top says I'm fine, I'm ready, because I'm just times. I'm ready to cancel, but the one on the bottom says no, we're a package deal. Remember, pluses and minuses glue stuff together like Costco. Package it, which means if you want to do anything with the bottom, you go like that and cancel the whole package, or do nothing. You buy the whole package or nothing like Costco, all or nothing, not just part of it when there's pluses and minuses gluing things together. So it has to stay as it was because we can't buy the whole package, so we buy nothing. Now, do they have the answer just like that on number 3? Oh, yeah, it's right there. Now, I want to give you a warning. I want to give you help that sometimes I get these test answer things off the publisher's website. They have a test generator. I just go on there and say, give me one problem with the x's in the power zone. I'll generally glance at it, make sure it's the general type I want. I just move it over. They have all the options, and I just hit the button, shuffle the options, and I print out the test. My point is, sometimes they will solve the problem and in a different way and get an answer that looks different than you might. It's not that they're trying to be difficult or weird. Basically, if they brought the x over to this side instead, it would end up looking different. So I want you to not be fooled by that. How do you not be fooled by that? Well, let me show you some other versions that would be the same answer. In fact, let me just bring it over here. So number 3, what do we get? Minus 2 ln 17 over ln 3 minus ln 17. Okay, over ln 3 minus ln. Because I've had students sometimes get fooled, or maybe you'll solve it a different way. Yeah, and I want you to get the points if you've done all that work. How about this answer? What if we had 2 ln 17 over ln 17 minus ln 3? Is that the same answer, or is that one different? What if you had this, and they didn't have anything that looked exactly the same, but they had like option C, that? Is that the same? Should you grab it, or should you do that none of the above? That's the same. You should grab it. So if you don't realize that, let me point out a couple algebra rules to help you realize those are algebraically the same. How do you know? Well, if you ever have an answer, and they have another one that kind of looks similar, but you're not sure, you can, and it looks like there's some sign differences. See how this has got a minus and this one's plus, You should try multiplying top and bottom by -1. Right? Because if you take anything, say like 2/3, and you multiply top and bottom by -1, -2 over -3, that's the same answer, as you know. That's a simple case. 2 negatives, that's positive, right? So if you ever multiply top and bottom by -1, whatever you get is a different version of the same thing, isn't it? Okay, so, and both are good. One's not any more simplified than the other. They're just different versions. So let's try. So that's what I'm saying you should try on an exam. Say you got this answer over here on the left, and you look at the one on the right, you go, I don't know, is that the same? Try, I'm going to go -1 in the top, -1 in the bottom. So what happens on the top? Well, negative times negative, positive, that looks good. Now, so far so good, but what about the bottom? When I multiply the bottom by -1, what does it do? Does it just go right on the ln 3 like that? Is that right?
No, it makes the ln 17 positive.
Right, it's got to hit them both. When there's two things. Again, this is the Costco thing. Now, that's a good analogy because those are two separate milks or whatever, but glued together. But they still are two. You tracking with me? So I want you to see both truths and keep both together in your mind. These are two things. So the point is that -1 will go to both of them, even though they're glued together. It's two things. So it'll be like that, right? Now, is that... We already verified that the new top matches, but is that the same as that?
Yeah, just switch it.
Yeah, remember, order doesn't matter. All that matters is signs in front. What's in the front of the ln 3? Negative. What's in the front of the ln 3? Negative. What's in the front of the ln 17? Positive. What's in the front of the ln 17? Nothing, which means positive. Yeah, they're the same. Grab it. That's the same answer. Do you see that? So you won't be fooled by that. So try multiplying top and bottom by -1. If what you get matches, that's the same as yours. It's just a different way of saying the same thing. All right. Good questions on that? That's about as... Okay, so here's number 4. X squared equals negative 16y. And they want you to find the focus point. Let me jump in. So again, you have to make it have the right look. Okay, and so the look is x squared is minus 4ay. Right? And so that means, actually, we don't really have to graph it, I guess. Really, but I'll do it anyway. Which way is this one going? Up, down, right, or left? Yeah, because remember, the right side is the direction, huh? The right side, first power letter, is the direction. Negative y, so it's going down. It's probably, and it's centered at origin 0, 0. How do I know? Yeah, it's not like x minus 3, and this isn't like y plus 2. Or there's no numbers added or subtracted next to x and y, which means it's 0, 0. Huh. Yeah, so it's centered at 0, 0. It's going down, okay? And so that means the focus is somewhere down here. How do I know where? Yeah, it's the A, huh? The A tells you, remember what A is? The distance from the center to the focus, that's A. Remember, A, B, and C, all those things are always distance from the center to whatever we're looking for. So what does A have to be so that these guys really make negative 16? A's got to be 4. You can just tell by looking at it, huh? A's got to be 4, doesn't it? So the focus is over 0, down 4. That's the coordinates of the focus, huh? Over 0, down 4. We good there? So I figured that out. I just used the setup, identified that A had to be 4. That's why they do those formulas, huh? They're saying make it look like this. So maybe I skip. If you wanted, I could have written it minus 4 times 4 times y. Same thing, right? So we see that the A has got to be 4, and we know it's down because of the picture. So that's down 4. Good. Like you can do that. All right, a lot of that stuff tricks people because it's easy to think it's left or different things. Practice just takes some time there. Okay. Okay, so they want the parabola equation. All right, let me draw a picture with you. So I'll do it over here. So the vertex is 1, 7, 1. So 1, 2, 3, 4, 5, 6, 7. So right there. Oh, that's not over 1, is it? Right there. Over 1. Over 1 up 7. Over 1 up 7. And then over 1 up 5 is the, so this is the focus point. This is the vertex. Okay, and so remember, the focus point is always inside the parabola, inside the satellite dish, so to speak, right? So which way is this parabola going? Up, down, right, or left? Down. Because the vertex is the center of the parabola, and the focus point is inside, huh? So this is another one going down, isn't it? Which means it's x squared is minus 4ay, because the right side is the direction, negative y. Right? Or you'll have those on your 3x5 card, so you'll know the direction right away. Good so far? So I've got the general form of the parabola equation. Okay, now the center is not 0, 0. So I got to fix that. The center is right here, 1, 7. This is the x value, this is the y. So it's opposite, right? X minus 1 squared. And y minus 7. Opposite of x, opposite of y. You remember that, right? Last thing is to find a. And I'll have the whole equation. What is a? If you need to, write those words on your 3x5 card. A is the distance from the center, huh? All those things, A, B, and C, are always distance from the center. So from the center to there, A is what? 2. A is 2. So put in a 2 there. This is going to be minus 8. There's our formula. Does that make sense there? Because the A has to be 2. Let's go find that answer. minus 8, y minus 7. B right there. There we go. Good. Questions on that? Now, I know you might be thinking, wait a minute, didn't we learn something special where, like, you've got to do like a divide thing? Yeah, that's if they give you the equation already and ask you A. Does that make sense? Like, what if somebody gave me an equation? Hey, I've got an equation. X squared is minus 7y. What's the A, please? Well, I would go, okay, well, it's got to be minus 4ay. Again, I would write out the form, the template. And I go, okay, what does this have to be, right? Because it's got to be minus 4 times something times y to really be back to minus 7. Well, then that would be, I would remember how that works? What could you put in there to make it work? 7 over 4, right? Because those would go back to minus 7, wouldn't they? So that's when you do that, is when you're going that direction. When you're starting with the equation and you're trying to make an A that fits. But on this one, I'm trying to find the equation. So I just look on the diagram and go, well, A is 2. Put an A is 2. There we go. See the difference? So it just takes practice. Just takes doing these problems over and over and over again. You can, the homework, you can redo those, right? You can go back. There's a practice mode. You can go back in where it won't mess up your grade, and you can just practice. Ask it for a new question. I'm sure that's what you want, right? It's more homework. But you can practice those more, or the prac exam. That's why I give you that other version of the prac exam, which is worth almost no points if you want to practice. Well, let's try to draw this thing. So to draw this thing, we've got to give it the right look, don't we? So it's got to have a 4, an A, and then the Y stuff, right? We know the correct look has to have a 4, and they all do. All parabola equations have a 4 and then some other number in the front. So you see how we're playing this game all the time? It's starting to seem easier. It's what math and science does all the time. They give you a certain form you need to put stuff in, and when you do, then you can tell what's what. So I've got to make it look like that without changing any values. So what's really in front is just a 1, huh? Nothing, so 1. So therefore, what does A have to be? It's got to be a 4th, doesn't it? So A is a 4th. That tells me A is a 4th because that's really still 1. Yeah.
How did we determine that it's going to be a positive? If it was like a negative 4 and we had a negative 1, 4, there's a negative.
Oh, I'm just saying there's a positive 1 right there, so the sign's got to be positive. Okay. Whatever sign it's already got, that won't change. Okay. Yeah, it's already positive. Good question, Aaron. Yeah, it's already positive, so we know it's a positive 4. If it was a negative 1, then it'd be negative 4. Yeah, you got it. All right, good. So, okay, so let's put that on the graph then. So, where's the center? Yeah, opposite. So back 1 down to right here, huh? It's going to go, okay, so back 1 down 2. There's the vertex, the center. And which way does this parabola go? Up, down, right, or left? Yeah, positive y, up. The right side tells the direction. So this one's going up, which means the vertex, the focus point is somewhere up here. Inside the satellite dish, it's always inside. Okay, how far up to the focus point? Yeah, that's what A is. A is the distance from the center. That's what all these things are. A, B, and C, they're always distance from the center, huh? So from there to there must be up 1/4. Up 1/4. So how do you add 1/4? Do I add it to the x coordinate or the y coordinate? Y, because up, down. So I'm going to add 1/4 to the y coordinate, huh? Yeah, now you can do that without a calculator, right? That's adding 25 cents. So you have a negative $2, and you're going to add 25 cents. So that's going to be negative 1.75, huh? We good there? Negative 2 plus 25 cents is negative $1.75. So that's got to be the coordinates of the focus point. I don't know, what do they want on this one?
Just find circle the right graph with the
Okay, so it's going up. It could be A. Let me try the other option. So this one's no because it's lower right. This one's no, it's going the wrong direction. So this is lower left corner. So is it C? Yeah, lower left. This is low. This is no. So it looks like it's C. There's none of the above down there though. So gotta be careful. Is the focus -1, -1.75? Yep. Is the vertex -1, -2? Yep. The directrix line, where would the directrix line be? That's back here, behind the shape, same distance away as the focus is. So that's 1/4 back. So back 0.25. From -2, that'd be -2.25. Yeah, that's right. It's all good. It's C. We good there? Shall we move on? We good? All right. This one. I wanted to get to that bridge problem with you. So let me crank this one out. So you know, to find the center, it's opposite, opposite. So back 1 up 2 right here. That's going to be too far. Well, I'll do it anyway. Right there. Back 1 up 2, opposite, opposite. That's the center. And now, you know what to do from here, right? This is 6 squared. This is 3 squared. Whatever's underneath x is right left. Y is up down. So right left 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And up down 3. 1, 2, 3. 1, 2, 3. So there's my ellipse. So what are the vertices? This one and this one. Those are the vertices, huh? They're the widest direction. We don't care about the smaller direction. It's the widest. So what's the coordinates that looks like? It's 1, 2, 3, 4, 5. Over 5. Up 2. And this one is back. What is it? 1, 2, 3, 4, 5, 6, 7. Back 7 up 2. Back 7 up 2. Over 5 up 2. Good there? Back 7, 2, over 5. There it is. Good on that? All right, on we go. We got to give it the right look. What look do we need? What do we need to do to this thing to put it in the right form? Yeah, because you got to get a 1 on the right side, huh? So divide through by 144. Yeah, now, do you know like 16 goes into 144? Yeah, if you're not sure, you can just go over here by hand and just try it. It turns out it's 9. 6 times 9 is 54. 144, there it is. So it goes in 9 times. And once you know that, you go, oh, 16 times 9 must be 144. So 9 must go in there 16 times. And so you get x plus 1 squared over 9 plus y minus 1 squared over 16 is 1. So when we go to draw this thing, the center again is opposite. Opposite. So the center would be back 1, up 1 right there. Back 1, up 1. And this is 3 squared, 4 squared. So it'd be right and left 3. 1, 2, 3. 1, 2, 3. Up and down for 1, 2, 3, 4. 1, 2, 3, 4. So it's a little taller. Something like that. That's probably enough to grab the right answer. Yeah, it's clearly D, huh? Does that make sense? We good on that? So there's problems 1 through 8. No calculator at all. Not too terrible. This okay over here? Just won't divide that over there. On that. So we can do all that with no calculator. Okay, so I want to go on.